Hi everyone, welcome to InfosecTrain. I hope you all are fine. So let's start with our webinar. So before starting the webinar, let me introduce myself. My name is Ashish Dhyani and I am working as a trainer at InfosecTrain. Talking about my certifications, I am Network Plus, Security Plus, CEH, which is Certified Ethical Hacker, and CCNA certified. Apart from these, I also provide trainings for A Plus, Pentest Plus, and CSA also, which is Certified SOC Analyst. Talking about my background, I have 3+ years of experience and I have provided trainings in government and non-government organizations. I have provided trainings for CCNA routing and switching. As you can see, it is written over here. And I have also provided trainings for Microsoft Windows Server, Red Hat Linux, CompTIA A+, N+, and also your cybersecurity trainings like CompTIA Security Plus and Certified Ethical Hacker. One more is there, which is not mentioned, which is CompTIA Pentest Plus. So I am, you can say, a subject matter expert for networks, and I'm pretty much good at networking and network security. So this is about myself, and let me tell you about the agenda of the webinar. So today we will be discussing about OSI model. Then we will move to encapsulation, decapsulation, and ARP, which is address resolution protocol. And then at last we will be talking about the things which we need to understand in defense, right? So let's start with our webinar. The first thing is OSI model. So what is OSI model? So your open system interconnection model is the reference model that we take for reference, right? We do not use OSI model, we use TCP IP model. But for understanding TCP IP model, we need to understand OSI model first. So there are 7 layers in OSI model. We start from the bottom: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. So every layer has its own work, what they do for data transmission. So if we cannot remember the names of the layer, we have a mnemonic that we call please do not throw sausage pizza away. So this is the mnemonic by which you can learn the names of the layers. Then what is the working of every layer? So let's start with the 7th layer, which is application layer. So application layer is the layer which is nearest to the user, like our browser. If we are browsing internet, so that is our application layer. Then the next is presentation layer. So in presentation layer, what happens? The encryption and decryption of data takes place. So the data is encrypted and decrypted at presentation layer for security issues, right? Then we have next, the 5th layer is session layer. So in session layer, what happens? The session is started. That if we want to, let's say we want to send an email to our HR or our boss. So what we do? We write a mail and send it. So what's happening over there? A session is created between you and the Gmail server. Then the Gmail server is created the session with your receiver. So what your receiver will do, he will get the mail. So that's how the things work. Then we have transport layer. So at transport layer, the segmentation of data happens. So the data is broken into segments and then it is sent to the further layers. So let's say if we have hello. So the data will be broken into these parts. The first segment will be HE. The second segment will be double L. And the last segment will be O. right? So that's how the data is broken. Then the data, the one segment reaches your network layer. So in network layer, what happens? Your IP address is added, right? So how it looks like? It looks like this. We have HE over here. We have IP address attached to it, right? So there are two IPs, your source IP and destination IP. So your source IP and destination IP is attached, and then it is forwarded to your data link layer. So your data link layer works with MAC addresses. So what happens in data link layer? MAC address is our physical address. So we need MAC address for sending the data, for creating the frame. So what happens there? Your destination MAC address and source MAC address is added. Your DMAC and SMAC, right? So this whole thing which we created at data link layer is called frame. When the source MAC address and destination MAC address were not added, it was only source IP, your destination IP, and the data. It will be called packet, right? Then the data from data link layer is transferred to physical layer. So what happens in physical layer? In physical layer, we have wires, we have physical layer devices like hubs, right? So what happens there? The data is transformed into bits, and the data is then transferred to the machine. And when the data reaches the receiver machine, so what happens? The data is again converted into frame, and then it goes to your data link layer. So what happens at data link layer? The data link layer checks the MAC address, the destination MAC and source MAC. So as the destination MAC matches to its own MAC address, it shreds that part and sends that packet to network layer. At network layer, what happens? Your network layer works with IP addresses. So your network layer checks the IP, your source IP and destination IP, that the destination IP matches with it or not. If it matches, it shreds that portion and sends the data to transport layer. So here we got HE. The same process happens with the next packet. So in the next packet, what happens? It comes to your transport layer sends it to network layer. Again, the IP address of source machine and destination machine is added. Then again, your data link layer adds MAC address, and then your physical layer converts it into bits. And the same process happens with the next packet, and it reaches transport layer. Then double L reaches. Then the last one is O. So with O, the same process will happen, and we will get O over here. So till the last packet, all the packets wait at transport layer. And the transport layer does what? It assembles the packets again, makes a segment, and then it forwards it to the session layer. Session layer gets that packet, that data, and closes the connection. Then what happens? When it goes to presentation layer. So here at presentation layer, the encryption happened. So here in the receiving machine, the decryption will happen, and the data will be received. And presentation layer will forward that data to application layer, and at application layer, user will open the browser and he can see that data on his screen. So this is the working of OSI model. So for understanding TCP/IP model, we have for reference OSI model, right? Then next, moving on to your encapsulation and decapsulation. So in OSI model, we discussed that every layer attaches something, right? Like your network layer attaches IP addresses, your data link layer attaches MAC addresses, right? So this thing is called encapsulation. So the data is encapsulated between different types of headers and trailers, right? So as you can see, at application layer, it is this only data. At presentation layer, it is same data. Session layer, it is data, but at transport layer, it gave it a header, which we call segment header, right? Then what happens? At your network layer, the packet header is added, like your IP addresses, your source IP and destination IP. Then at data link layer, what happens? Your frame header is added, which is your MAC address, right? One more thing is added at data link layer, which is frame trailer. So what is this frame trailer? This is your FCS, which is frame check sequence. So what is there in FCS? FCS has CRC, cyclic redundancy check. So what it does? Let's say if you are sending some data and due to some errors, the data or the packet is lost, or there are some errors occur in that data. So your FCS checks all those things, that if the data is changed, modified or not, right? So that is the work of your FCS. Then at physical layer, the data is converted into bits, as you can see over here. The data is converted into bits, and the shredding of IP addresses and MAC addresses and all the headers, it is called decapsulation or de-encapsulation, right? So what happens at data link layer? The MAC address is shredded. Then at network layer, your IP address is shredded. It checks about the IP address and it shreds the IP address. Then at transport layer, it sees that transport layer has started the communication, because transport layer starts the communication with a thing called three-way handshake. So in this, if it is TCP, transmission control protocol, so then it will start the communication with three-way handshake. So it checks whether it is TCP or UDP, user datagram protocol, right? So that's how the encapsulation and decapsulation of data is done, right? Now let's move on to our R, address resolution protocol. Like as you can see in this diagram, we have one host, we have a router, and we have these devices also connected to the same network. So how the data is transferred? So for transferring the data, the device has to create the packet, then it has to convert it into frame. So for that, he will be needing what? He will be needing the IP address and MAC address. So IP address is our logical address and MAC address is our physical address. IP address, the length of the IP address is 32 bits and the length of the MAC address is 48 bits, right? So this host wants to send data to this PC, let's say. So what it will do, he knows the IP address of that PC, right? So what it will do, it will create a packet in which he has the IP address written. So whose IP address will be there? This PC's IP address will be there. So he will write anyone having the IP address of 34.40.21.20. Please send me your MAC address. So what will happen? This data, the our request he will be sending, it will be a broadcast. So he will send that broadcast to everyone present in the network. So as soon as this PC will get that request, he will check the IP address and he will say, hey, this is my IP address. So he will reply back to this host. So that reply will be a unicast. It won't be a broadcast. This reply will be a unicast. So then the host will get that MAC address of this PC, and then what will happen? He will create the frame and with the MAC address, destination MAC address of this PC, and he will forward that to the router. The router will check the IP address and the MAC address, and he will send forward that data to the PC. So we have this R for mapping MAC address with IP address, right? So if we want to ping this PC, so that's how he will get the MAC address of that PC, and then he will start to ping, right? So ping has two parts. If you know, ping is a utility which uses ICMP, Internet Control Messaging Protocol. So ping has two parts, your echo request and echo reply. So when it is finding the MAC address of the receiver, so he is doing what? He is requesting. He will send echo request. And then when this PC will reply back with his MAC address, so that is called your echo reply, right? So that's how your ARP works. So this is the working of ARP. It resolves MAC address with the IP addresses, right? So your encapsulation and decapsulation is related with ARP and how it finds the MAC addresses and all, right? So this is the working of ARP, and we discussed about encapsulation and decapsulation also. Then the next thing we have is IP routing theory. So when we are connected in the same network, we know we can enter the IP address of the device and it reaches the device we want to send the packet or data. They are connected in the same network. So let's say this router has one more device connected. So what will happen? H1 will request the router. H1 will send an ARP request and asking the MAC address of your this PC, right? But if we don't have this PC in the network, so what will happen? Let's say we are talking about this. This IP address is 192.168.1.1 and IP address of the receiving machine is 192.168.2.2. So these both devices belong to different network. So how the data will be sent? So let's say we have this device H1. So how will the data or the ping will be sent to this device H2? So what will be happening? We will be discussing about routing. So what is routing? Routing is a layer 3 function. So routing is a process of going from one broadcast domain to another broadcast domain. But how the data will be sent? So let's say host 1 wants to ping host 2. He creates ICMP echo message with source IP address of his own and destination IP address as 192.168.2.2, right? So for sending that, H1 needs to create a frame for transmission on local database, right? Your layer 2 controls transmission on local data link layer. So that's why it is called data link layer, right? So what will be happening? Let's say H1 has this MAC address. So let's say for suppose it has a MAC address of AAAA, right? So how the data will be transferred? H1 does not have the MAC address of the second machine. So what it will do? He will send a ARP request in the whole network. So as soon as he will send the ARP request asking the MAC address of this machine, router 1 will get that ARP request. So when the ARP request reaches the router, so what router will do, router will check his whole network and he will find out that this device is not connected inside my network. So what router will do, router will provide his own MAC address to the host 1. So this is called your ARP proxy. Right? So your R proxy is what? In this R proxy, this is a protocol, default protocol in routers. What they do when they do not have that IP address, the MAC addresses, or they do not have the networks, the devices in that their network. So what they do, they send their own MAC address in reply. So what will be happening? H1 will get the MAC address. So he will create a frame in which the source IP will be of his own with this one. The destination IP will be of this PC, the receiver machine, but the MAC address will be of the destination MAC address will be of the router, right? R1, and source MAC address of his own. So that's how he will be creating the frame. And then what will happen? The same thing will happen. The data will be received to the router. Then what router 1 will do? Router 1 will check the MAC address and the IP address, the destination IP address and destination MAC address. So the destination MAC address belongs to him and destination IP address is of this H2 machine, host 2 machine. Now, how he will be finding that where this machine is? So as you can see, these two devices, your R1 and R2, are connected serially. It is called serial connection. Serial connection means these devices, your R1 and R2, are connected directly to each other with a wire, right? So what R1 will have, every router has a table which is called IP routing table. So every router has a IP routing table, or we also say it routing tables, right? So what is that routing table? It has a list of all the remote destinations that are available to the router, right? All the remote destinations that are available to the router and how to get to them, or what interface to use to send the data toward that remote destination. So what router 1 will do, it will extract the original packet and it will match the destination network in the packet with all the networks available to that router. So he will be checking all the IP routing table and he will be checking all the networks that is available to him. So what will happen? Your router 1 will find out that network 192.168.2.254. This is out of the port GI gigabit port 0/2. So what will happen? He will find out that if he will send the data out to this port, so that port is connected to the second router, and in that second router, the router has that IP address, right? So what will happen now? Your R1 will send the ARP request, right? So he will ask the router's MAC address, right? So when he will ask the router 2's MAC address, router 2 will reply him, and what will happen? Then R1 will create a frame, right? So what will be inside that frame? In that frame, there will be router 1's source IP and the destination IP will be of your host 2 machine. Then it will be having your source MAC address as his own and the destination MAC address of the R2, your router 2, and he will forward that frame to router 2. As router 2 will get that data, so what will happen? Router 2 will check, will de-encapsulate that. So first he will be checking the MAC addresses, right? So he shreds the MAC address, then he will be checking the IP addresses at network layer. As the IP addresses match, he will shred those IP addresses, right? Then he will be left with data, and in IP addresses, the IP address was of your host 2 machine. So what router 2 will do, router 2 will check that if that device is in my network or not, and if that device is inside his own network, what he will do, he will send the ARP request to this host 2, and what will happen in host 2, the host 2 will reply back with his MAC address, right? So when he will be sending back the MAC address, what R2 will do, your router 2 will again create a frame. So in that frame, the source MAC will be of router 2, the destination MAC will be of host 2, the source IP will be of router 2, and destination IP will be of this machine, right? So then he will forward that data, and at H2, your host 2 will find out that data, will get that data, and he will find out that if that thing belongs to me or not. So he will check the IP addresses and MAC addresses, and if all these things match, then what will happen? The data will be reached to host 2, right? So that's how the things work. Then we discussed about three-way handshake, right? In previous slide, we discussed about three-way handshake, that in transport layer we have three-way handshake. So what is a three-way handshake, right? So we have in your transport layer, there are two things, two types of protocols, TCP and UDP, right? So in TCP, what happens? It is called Transmission Control Protocol, right? Your UDP is your user datagram protocol, right? So what happens in TCP? When you are doing a communication that needs acknowledgement, so there we use your TCP. The best example will be your email. When we send an email, right? So what happens when you write an email and send it, at bottom left of the screen here, a message comes, that message sent, right? So what is that? That is acknowledgement. So that's why your TCP is called connection oriented protocol. And when we talk about UDP, so UDP does not have any acknowledgement. It does not send any acknowledgement. So that's why we call it connectionless protocol. So what is the difference? That if you are sending data through TCP, So what will happen? The data will reach without any packet loss, right? So in TCP, you are sending the data without any packet loss. So we can write over here, no packet loss. But if you are sending data using UDP, so what will happen? There can be packet loss. Like the best example for UDP is our video calls. So what happens in video call? When you are doing video calls, when you are FaceTiming someone, so what happens sometimes due to network errors, we are not able to hear the whole voice, or we cannot, sometimes the video gets paused or something. So that is your UDP. It does not give you an acknowledgement, and it does not gives you the guarantee of no packet loss. But why we use UDP? Because in video calls, let's say if we are doing a video call, what will happen? If we are using TCP over there, so in TCP, every frame will get a acknowledgement and the communication will not be good. So that's why we use UDP. Then if we are using TCP, so how the connection is started? So transport layer tells that whether it will be using TCP or UDP. If it will be using TCP, so the communication will be started with your three-way handshake. So what is your three-way handshake? It is a type of handshake when we start a communication. Like if we are talking, so how will we start our communication? By hello. We'll say first hello and then we'll start our communication. So that is how all the machines work. So let's say this is a sender machine and this is a receiver machine, right? So what will be happening over here? First, it will be sending a synchronization flag to his receiver. So this is a sender, this is a receiver. So we have TCP flags. Anyone knows about TCP flags? What are TCP flags? So we have 6 types of TCP flags. Your SYN, ACK, FIN, right? We have reset, we have push, we have urge. So we have these 6 flags which are used in communication. So what will happen? Your SYN stands for synchronization. Your ACK is acknowledgement. Your FIN is for finishing the communication. We have RST for reset. We have push for pushing the data. We have urgent. So if we have some urgent data, so we will send that data using urgent. So when we start a legal communication, right? So the best flag to send is SYN. You can say it is a type of hello for your TCP communication. So it will send a SYN flag, and what will happen? Your receiver will get that flag and he will reply with SYN ACK. So why he sending SYN ACK? Your sender has sent synchronization flag, right? So he is acknowledging that flag and also sending a synchronization flag for starting the communication. Then what will happen? Your sender will again send an acknowledgement flag, right? For synchronization flag sent by your receiver will be acknowledged by your sender. So that's how your three-way handshake works, right? So your SYN flag, SYN ACK flag, and acknowledgement flag. After that, after doing three-way handshake only, you can send the data, right? Then we also have four-way handshake. So we have started the communication with three-way handshake. So how we will close the communication when the data is sent? So there we do four-way handshake. So what is that four-way handshake? So your four-way handshake is used to close the communication, right? So what happens over there? Let's say we have these, your receiver and the sender. This is your sender, this is your receiver. When you have sent the data has reached to the receiver. So how will this close the communication? First, your sender will send a flag for finishing the communication, which is fin flag. Then your receiver will send your acknowledgement flag that yes, I also want to close the communication, right? Then receiver will again send a fin flag for finishing the communication from his side, and the sender will acknowledge that flag with ACK flag. So that's how your four-way handshake works. So if we want to start a communication, or your TCP communication, we will be starting it with your three-way handshake. And if we want to start the communication without TCP, so it will be started without any three-way handshake. And if we want to close the communication, then the communication will be closed with your four-way handshake. So that's how your things work, right? Then we are left with, we discussed about these three flags. We are left with these flags. So when these flags are used, so your reset flag is used when you want to abruptly close the communication without any acknowledgement. What it will do, it will just close the communication abruptly. Then we have our push flag. So when we want to send data, we have a container. Let's say we have a container. So what it will do, it waits until it is full, right? So if it is not full and we want to send the data, so we will send the push flag with it. So what will happen? The data will be pushed to the receiver machine, right? To the receiver. So that is why we use push. The buffer is not full, but still we are pushing the data to the receiver. Then we have urgent flag. So in urgent flag, what happens? The same thing happens like push, but we send urgent flag because we have some urgent data to send, right? So let's say we have some urgent data, so we will add the urgent flag with it and we will send that packet. So what is the difference between your push and urgent? Because as we can see, they have the same working. So in push, what happens? The data is sent sequentially. So when we are sending some data using push flag, so the data is sent using the sequence. But when we are sending the data using the urgent flag, so the data will be sent sequentially, not in the sequence. So no sequence is there. So for sequence, then the receiver's transport layer works and reassembles that data again. So that is the difference between your push and urgent. Your finish and reset also have the same working, but your finish is the legal way to stop the communication and your reset stops the communication abruptly, right? And these are your urgent and push flag. So This was all about this webinar. So if you want to contact us, these are the details through which you can contact us. Thank you everyone.